Okay, so we're in part 2 now of solving miscellaneous problems using trigonometry. And our next example here, we've got an avalanche. After an avalanche, helicopters used to locate people trapped in the snow. When the helicopter H, now I don't think the H is in the drawing, so I'm just going to put that in there straight up. There's our point H. Was flying 300 metres above the snow. The pilot located person P trapped in the snow. I'm just going to make that a bit smaller so we can see. And at an angle of depression of 20 degrees. At the same time, the angle of depression to the rescue squad R was 15 degrees. Points R, D, and P were in a horizontal straight line. So calculate the sizes of angles alpha and beta. So a reasonably easy start here. I'm going to do part A over here. So obviously both of these are 90 degrees. The height from the ground is measured as a perpendicular height. So alpha is just going to be equal to 90 degrees minus 15 degrees. So that's going to be 75 degrees. And beta is going to be 90 degrees minus 20 degrees. So that'll be 70 degrees. Okay, next we have to use in part B, we have to use triangle RHT to calculate the length of RD. So in relation to that, we've got an angle that we know the size of, we've got an adjacent side, and we've got an opposite side. So, and we know the height of the adjacent side, the opposite side is what we're trying to find. So opposite over adjacent, we're thinking of tan. So tan theta equals the opposite over the adjacent. So in this case, it's going to be tan of alpha is 75 degrees. Whoop. Equals our opposite, which we don't know, so that's RD, over our adjacent of 300. So if I multiply both sides by 300, I'm going to end up with RD equals 300 tan 75 degrees. And I can just plug that into my calculator. And we end up with, what does it say? Just calculate the length, so it doesn't tell us how many decimal places, but might just go to one decimal place. So 1,119.6 meters. Okay, and then for part C, we want to find the length of DP, so that's this distance here. So once again, we've got an angle, we've got an adjacent side, and we've got an opposite side. So very similar to the last one. So we're just going to use the same formula again. Tan theta equals the opposite over the adjacent. In this particular case, that angle is 70 degrees. So tan of 70 degrees equals the opposite side. Well, that's DP. That's the bit we don't know. Over the adjacent side, which is 300. So once again, we're going to end up with DP equals 300 times tan 70 degrees, because we multiply both sides by 300. And I can even just go in here and just change that to 70. 300 times tan 70, that's everything we need. So that's going to be 824.2 meters. And then finally, I think we're just asked to find the distance between the two. So that's just going to be, for D, the distance is just going to be DP plus RD. And we've just worked out those, so that's going to be 824.2 plus 1,119.6, I think it was. Yes, it was. So we'll add those two together. 824.2 plus 1,119.6, and we get 1,943.8 meters. And that's, I think, everything we need to know. We might say something like, therefore, distance to what they call the rescue squad and the to trap person is 1943.8 meters. Okay, and our final example we're given here is we've got an advertising blimp, and so during a country fair, the advertising balloon flew above a lake from points X and Y 500 meters apart, and on opposite sides of the lake, the angles of elevation are 55 and 42 degrees. So we want to find first the angle XBY. So a little bit hard to see there, but that's Y there. So we first just want to find that angle in there. Well, that's just using the sum of angles in a triangle. So angle XBY is just going to be 180 degrees minus 55 degrees minus 42 degrees. Plug all of that into our calculator. 180 minus 55 minus 42 gets us 83 degrees. So we're ready to move on to the next part, part B. Okay, so using the sine rule in triangle XBY, so that's the big triangle, use the sine rule to show that BY is 413 meters. So that's the side we want to find here. We need to find the length, the distance there. Now we're looking for pairs again. So in this particular case, that angle pairs with that distance, and that angle pairs with that distance. So we've got we know the angle at the top, we know the angle at the side, so we know everything we need to know. And remember, so this looks like a case for the sine rule. Remember, with the sine rule, we want to leave the thing that we want to know at the top left. So that distance BY is opposite the angle 55 degrees. So that over sine 55 degrees equals, what's the distance on the other pair? It's 500 meters over the angle, the sine of that angle, which is 83 degrees. So if we multiply both sides here by sine 55, that's going to cancel those two out, and we're going to be left with BY equals 500 over sine 83 degrees times by sine 55 degrees. So we'll plug that into our calculator, and hopefully it'll equal what it said it should equal in the question. So 83, close our brackets, and we multiply that by sine 55. So 412.65 which is approximately equal to 413 meters, which is exactly as it says. So we've used that to show that. And then finally, the last part of the question is, it says, hence find h, the height above the balloon. So now that we know this side, we'll think in this final question, we'll use the triangle on the right hand side here. That's just a right angle triangle. So we're going to, for C, we're going to have, we've got this angle here. We want to know the height of the triangle, so that's our opposite side, and we know the hypotenuse. We just work that out in part B. So if it's the opposite in the hypotenuse, then we're using sine. So sine theta equals the opposite over the hypotenuse, and in this case that means that sine 42 degrees equals the opposite, which we don't know, that's just called h in the question, over the hypotenuse, which was 413. So if I multiply both sides by 413, I'm going to end up with h equals 413 times by sine 42 degrees. And if I key that into my calculator, so 413 times by sine 42, and we get 276.4. meters. Did it say to us? Doesn't say how high, so there we go. So it's 200. So it has asked us a question to answer those, so we can say therefore balloon is 276.4 meters above the lake. And that's all for that lesson. This is one of those situations where there's some questions set, but realistically, the more of these you can do, the better. Try and see if you... certain times you might be able to notice a different way of solving the problem too. So see if you can spot a second way of going about things. That's always handy to know. But yeah, the main thing is just getting used to picking out the technique to be used and then applying it correctly. And I will see you for the next lesson.